We're going to talk, do 11.4 and 11.5 today. 11.4 is circumference and arc length. 11.5 is areas of circles and sectors. So before we found the area and arc measure, today we will find circumference and arc length, and today we will find areas of circles and sectors. So circumference and arc length. Okay, here's a warm-up. Ratio of perimeter and area of triangles, then find x. So the ratio perimeter is 5 to 6. The area perimeter is 25 to 36. X would have to be, they don't tell you what X is here. If X is a side length,
there's a picture on our notes.
Oh, you have a picture? Okay. All right. So you would have so you have your perimeter ratio is 5 to 6. So you don't really need to square the ratio. It's 5 to 6. You do 5 to 6 as 8. If I can get my pen to write, 8 is to x. So you get 5x equals 48. So x equals, take x equals 9.6. So that's just straightforward similar triangles. You're using similar triangles here. All right. Vocabulary: circumference. Circumference of a circle is the distance around a circle. It's the distance around a circle. So if I took a circle, Mr. Moore. All right. No, he hadn't been here all year. I'm all semester. All right. Bye. All right. So we have this circle. To do the circumference, it's the distance around. So if I took this circle, let's say I took this circle and I cut it right here, and then I unwound it, I flattened it out, right? That distance, as I unrolled it and made it a straight line, that is your circumference. Arc length. Arc length is the portion of the circumference of a circle. Arc length is the portion of the circumference of a circle. So, yeah, the dotted black line, that would be the arc length. Again, if you flatten that out, that length would be the length of the arc. So the black line is the arc length. Everybody ready to go on? All right, circumference of a circle. The circumference of a circle is C equals two pi r or that 2r is the same thing as the diameter, pi d. The 2 pi r is a more common one that you use, but you can also use pi d for circumference of a circle. It's the same thing. You're just substituting diameter in for 2r. Find the radius of a circle with a circumference 26 meters. So again, I'll just write the general formula. Circumference equals 2 pi r. And then we plug in what we know. We know 26 for the circumference, so 26 equals 2 pi r. We have to solve for r. R equals 26 divided by 2 pi. And then, so that value, what would be 26 divided by 2 pi? (26 divided by 2 pi). Okay, I think what you did, and that's why I had you calculate this, I think you divided by 2 and then multiplied by pi. You got to put 2 pi in parentheses. Aaron, 4.14? Sounds right. 4.14 meters. Everybody understand? When you do this in your calculator, you've got to put the 2 pi in parentheses, because if you do 26 divided by 2, it divides it by 2, and then if you do pi, then it multiplies by pi, unless you put what you want to divide by in parentheses. So here's the work. Yeah, 4.14 was the answer. They should have units. They didn't give units. Should be meters. Tire revolutions. The dimensions of a car tire are shown. To the nearest foot, how far does the tire travel when it makes 15 revolutions? All right. So how would we approach this? How would we solve this? Do we have enough information to find the circumference? Yeah, you have the diameter. The diameter is equal to, we add all these up, right? 15 plus 11. 26 is the diameter. How am I going to get 15 revolutions? What do I do? If I want 15 revolutions, Carly, what would I do?
Multiply 26 by 15.
Not 26, not the diameter.
The circumference.
Yeah, do the circumference. Find the circumference. I think what you said would work, Carly, but the logic, I would rather you think, okay, we want to do 15 times the circumference, which equals 15 times pi d, and then we plug in, so 15c is what we need to have, equals 15 times pi times 26, all right? So we multiply that out. What do you get for that value to the nearest hundredth? Pi 26. What'd you get, Logan? Didn't get it? Ryan? Yeah, go ahead. Okay. What's that? 81.68. No, 15 times 26 is going to be more than 81. 1225 point what? 0.26. Come on, right. 26. And that would be inches. Right? It's not squared, it's a distance. 1225.26. All right. They want us to they wanted it in feet. Okay, so what am I going to divide by? To convert inches to feet, what do we divide by? It's a length, it's not an area, it's a length, so I just simply divide by what? Come on. 1225 divided by what to convert inches to feet? 12. All right. So we get 102.1 feet. All right, now we're going to do arc length. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. So what this is saying is, I can find the arc length of AB if I take the measure of AB with the measure of that angle. That gives me the fraction of the circle the arc length covers, right? Whatever the degree is, say this is 80 degrees. 80 degrees divided by 360. That tells me, okay, that fraction, 80 over 360 of the circle is covered. And then I multiply it times the circumference. And that's going to give me this arc length. So arc length is you're using circumference, but you're taking the fraction of the circle covered by the arc, and that's represented in degrees. Don't worry about the top one. Just use this one. This is the one I want you to. Go back. Come on. This is the one I want you to use right here. Here's what it looks like. Find the arc length of each red arc. Okay? So our formula is arc length is equal to m over 360 times 2 pi r. We plug in, we get 60 over 360 times 2 pi 8. And then you do the math. All right? So that's going to be 60 over 360 is 1/6 times 16 pi. Multiply it all out. You should get your answer. What'd you get, Kaylee? 8.38. 8.38. That's going to be centimeters. Arc length is still length. It's not squared or anything. It's just straight centimeters. All right, let's do another one. You guys do this one before I set it up. Do this one on your own. All right, so we would have this equals to 120 over 360 times 2 pi. The radius is 11. All right, so that, what did that number give us? What did you get, Jacob?
23.03.
23.03, and that would be centimeters. Let's see if that's correct. So we plug in, yep, 23.04, rounding, make sure you round correctly. Just, you needed to round up instead of down there. 23.04 centimeters. All right, now, a little bit different here. They want us to find the circumference of Z, and we know the arc length. It's still a matter, write the formula, area, arc length equals m over 360 times 2 pi r, right? And then we plug in, so arc length is given as 4.19 is equal to 40 over 360, and then 2 pi r is what? What is 2 pi r? It's the equation for what? Circumference. So we plug in c. Then we solve for c. So when we solve for c, okay, we would take c is equal to 360 over 40 times 4.19, right? Because to clear this fraction, to get c by itself, we multiply by the inverse, right? To make that 1, so that's why I multiply by 360 over 40 times 4.19, and what do we get? 37.71, and that's inches. Inches. Okay, any questions? Okay. So the whole key is write the formula up front and then just plug in what you know. All right. They want us to find m of rs with an arc over it. Means they want the degrees, the measure of that arc in degrees. The arc measure. Okay, so they want the measure of rs. So it would be this way. It would be going the shorter way around. It's a minor arc. They want that in degrees. All right, so we still write our formula. arc length equals m over 360 times 2 pi r. And then we plug in arc length equals 44 equals m over 360 times 2 pi, and my radius is 15.28. So we have to solve for m right here. We've got to solve for m. So to do that, I need to clear the fraction. So I would multiply both sides by 360. So it becomes 360 times 44, right? And then also to get m by itself, I would divide by all this. Both sides divide both sides by that. So I can divide 360 times 44 by 2 pi 15.18. That equals m. Alright? So calculate that. Remember, when you divide by the 2 pi 15.8, you have to put it in parentheses. Alright, so calculate. Make sure you can calculate the answer here. 360 times 44 divided by the quantity 2 pi 15.18. See what you get. Faith, you get an answer?
I think you're at 166.07.
166.07. Anybody concur with that? What did you get, Abby? 95.96? Well, let's see what the slide says. $165 is what they got. 165. All right. Let's see what. Did you take 360 times 44 before you divided by that? You did.
Yeah. You did it differently than that, though.
What's that?
You did it differently than that.
No, I just had the 360 times 44 on top. I just had 360 here, but it's the same. It's the same thing. This is 360 times 44 divided by 2 pi, 15.28. Yeah. Oh, it's 15.28, not 0.18. That's why you're off. All right. Okay, so here's an application. The curved ends of a track are shown are 180-degree circles, or arcs of circles. The radius of the arc for the runner on the red path is shown as 36.8 meters. How far did this runner travel to go once around the track, round to the nearest tenth of a meter? Okay, so they're wanting to know the red distance around the track. Anybody have an idea how we could approach this? How could we approach this? All right. Well, you've got, if we take these ends right here, take that end off and that end off, right? I could do, you know, half a circle here and then add the lengths of the straightaways and another half circle here, but I can, even though it's not in the picture, they're not together. What can I do with these two ends? What do they make?
360.
Yeah, they make a circle. So you're going to do. We can do it as a circle plus the two lengths of the straightaways. Right. So our distance, the distance, is going to equal to 2 pi r. That's the circle part. Plus 2 times the length of the straightaway. So then we plug in. That equals 2 pi. The radius is 36.8. 36.8 plus 2 times 84.39. Multiply it all out. See if you can get the calculation. Go ahead and multiply it out. What did you get, Faith?
I have
400?
400.
Exactly?
Yeah. 400.00.
Okay. Anybody else get 400? Aaron got 400 too? All right, let's go with it. So 400.00 meters. So that's, well, we know a track is, what, 400 meters, right? So that sounds right. Okay. So they do, there's the work, 400 meters. All right. So we have another section to cover. So on the, remember on the quizzes, we'll be giving you the formulas, not telling you what they are, just the formula. And you will have to identify which one to use and then apply it. I would probably be a good idea to be making yourself a formula sheet for your chapter summary sheet for this chapter. All right. Areas of circles and sectors. Area of a circle is pi r squared. Area of a circle is pi r squared. Use the formula for area of a circle. All right. Find the diameter, if it has an area of 113.1. Okay, so we're going to write the formula. Area equals pi r squared. And then we're going to plug in what we know. 113.1 equals pi r squared. So then we have r squared equals 113.1 divided by pi. So then r is going to equal to the square root of 113.1 divided by pi. Go ahead and calculate the radius. And then we're not done once we found the radius. We've got to find the diameter. But go ahead and calculate the radius. What do you get for the radius, Kaylee? 10? What? 6? All right. So radius equals 6. So then the diameter, I'm going to clear that out. The diameter equals 2 times the radius. So it's going to equal 2 times 6. So the diameter equals 12 centimeters. Is that what they got? Yeah, they got the diameter is 12. All right. Any questions? Okay. Sector of a circle. Sector of a circle is a region bounded by the radii of the circle and their intercepted arc. The red section in this triangle could be considered a sector. It's a piece of the pie. Now, this is very similar to arc length. But instead of finding this distance around the edge of the circle that's covered, we're finding the area. But you're still going to use the arc measure of that arc, right? It's still going to make that same fraction. Whatever degrees this covers over 360, but instead of multiplying by the circumference, the distance, we're multiplying by the area of the circle. So learn this one. Area of a sector the area of a sector is the measure of the arc of this sector over 360 times pi r squared. Area of the sector equals the measure of the arc over 360 times pi r squared. Let's see how it looks in an example. Find the area of the small sector. So they're talking about the pink. Find the area of the small sector formed by angle UTV. So here's how we're going to do it. We're going to say area equals m over 360 times pi r squared. So that's going to equal to 70 over 360 times pi 8 squared. So multiply that out on your calculator, see if you can get the right answer. 70 over 360 times pi 8 squared. All right, here's the answer you should get. $39.10, and then your answers would be in units squared because they don't give a unit, so you would write units squared. Questions? All right. Looks like we have another example. Find the area of the large sector. So what color would the large sector be? Logan? Yeah, okay. It'd be that blue, it'd be the, yeah. It'd be the part bounded by FGE. Good. So what do I need to do before I plug in my formula? What do I have to do? Kaylee? Yeah, we have to get the measure of the blue arc. And so it's going to be 360 minus 120, so it's going to be, that's 240. Right? That's 240. So we have the area equals m over 360 times pi r squared. So that's going to be equal to 240 over 360 times pi times the radius is 14 feet squared. That should do it for us. Go ahead and calculate your answer. One thing you could do, you don't have to, but you could reduce the 240 over 360 to 2/3, right? 2 over 3. That would make your calculation a little bit easier. All right, the answer you should have gotten is 410.50 feet squared. Feet squared. Any questions? Everybody has it all. Okay? All right, looks like we got one more example. You ordered a 12-inch pizza. All right? Cut the pizza into fourths to share with your 3 friends. How much pizza did each person eat? So when they tell you the size of a pizza, what are they giving you? 12 inches is what? It's what?
Radius.
Is it radius or diameter?
Maybe diameter.
Yeah, I think it's diameter. So the 12-inch pizza would be the diameter of the pizza. 12 inches, right? So if we cut it into fourths, what degree of would 1/4 of the circle? What degree would that represent? 90, right? It's 90 degrees. So we can do our area that one person eats is, we can do 90 over 360 or we can do 1/4. Either way, let's do 90 over 360 so you're seeing that that's the degree measure. So we have 90 over 360 times pi r squared. What's r going to be? What do I plug in for r? I don't plug in 12. What am I going to plug in? 6. Right. We have to take r equals 12 divided by 2. So then we're going to have the area equals 1/4. I reduce the 90 over 360. 1/4 times pi 6 squared. So that's going to be 36 divided by 4 is 9 pi. Okay, each person would each 9 pi inches squared. And they probably multiply that out. I missed the answer. All right. Then we've got area of a sector theorem. Okay, this time they give you the area, Okay, they give you the area. You have to find the they want the area of the whole circle. Okay, so what do I need to know to find the area of the whole circle? What would I need to know? We need to know the radius, right? Area equals pi r squared. We need to know the radius. I can find the radius here by doing my area of a sector theorem. So we'd have area equals m over 360 times pi r squared. So that's going to be 35 over 40 over 360 times pi r squared. Then we have to solve for r. So we solve for r. We've got to clear the fraction, so we got to multiply 35 times 360. So we'd have 35 times 360 and then we would divide by, so we've got rid of the 360, now we got to get the 40 pi over to the other side, so we divide by 40 pi. And we get that equals r squared. So you're going to remember when you divide by 40 pi, you put the 40 pi in parentheses. Okay, so what do you get for r? Let's make sure everybody can get r. What do you get for r? Aaron, what'd you get? 10? Was that r squared or r? You got r squared? Huh? All right, yeah, so you're going to take the square root of all this once you find it, so you get r equals 10. All right, then we plug into area equals pi r squared, so area equals pi 10 squared, so it's going to equal to 100 pi. Would be our area, meters squared. All right, any questions? Okay. We're going to skip this example. Find the area of the figure. Okay, so you've got half a circle and a right triangle. So the area is going to be area equals 1/2 pi r squared plus 1/2 base times height. So that's going to equal to, the area equals 1/2 pi 3.5 squared plus 1/2 7 times 7. I'll multiply it all out. And I should get my answer. So if we do the math, we should get 43.74. right, one more here. Let's see, this one. Find the area of the shaded region. Okay, so without the shading, the region is a what? What shape is it? Without the circles. What is it? It's a rectangle. So then how many circles do we have in there? 3. So this is going to be that we get the area. Area equals the area of the rectangle, base times height, minus 3 pi r squared. And then you'd plug in. All right? Any questions? Okay.